evening, my friends. So, yeah, thanks for the wonderful introduction. I'm Dr. Binesh Jose, working as a senior manager for a US consulting company and in charge of advanced technology space, that's cloud, big data, and artificial intelligence for a multinational organization. So today we are planning to cover how the artificial intelligence and machine learning are evolving in recent years. And what's the reason for that? Because as you know, these are not new technologies. These either machine learning or a deep learning or artificial intelligence, it's a pretty old one. Why? What's the significance of this technology today and where we are heading towards? So let me start with my presentation. Can I share my screen? Yeah, probably yes, right? So topic for today's session is role of AI and ML in the new era. So while preparing this PPT, probably 2 days back, when I'm doing an internet search, this is the first thing that comes into my attention. So it's a news from Reuters about the ongoing Tokyo Olympics. So the swimming Aussies dive into data lake being success in Tokyo pool. So since the data lake is there, it's got into my attention. So it's about how artificial intelligence and machine learning, maybe data analytics, a team or a nation is effectively utilizing. It's a very good example. So when I'm comparing the Aussies swimming team with 2016 in Rio de Janeiro to Tokyo in 2021, they had just 3 gold medals in 2016 Olympics. And as you know, it's a game of physical. That means it's a sports. It's activity of depends on your physical abilities. And even I cannot imagine what technology did in this context. So I just went through that news. So then we identified, the news explaining is something like, so this is a historic moment in Aussie's swimming team history because they bagged around 9 gold medals. That's the best ever performance from the Olympics. That means 3 gold to 9 gold within the period of 5 years. 2 years before they are arriving in Tokyo, that means in 2019 or 2018. So what miracle they did? That was the question. So 2 years before, when they arriving in Tokyo, Australian swimming team or their management implemented something called data lakes on top of Amazon Web Services, and they implemented a set of data analytics as well as data science platform. When I say data science, it's artificial intelligence, machine learning, and deep learning primarily. Data science platform. So it's pretty interesting because in the game of your physical ability, how this technology can help you. That's a very important context, especially on this scenario. So what they did is they made they tuned the performance of all the athletes, especially on swimming, by understanding their strength, their weakness, and analyzing their each and every moment. So where they are lacking, because from last so many years, they were in participating in the swimming, and United States or some other nations, especially China, US are the they are the leader in that space. So these guys are analyzing why they are the leader. So what make them the perfect? What make them better than us? They analyze that particular topic and they came across a set of answers, evidence-based decision points, so that their management planned, okay, we may need changes in a training plan or the way we are taking the exercise or maybe our food habit. So they made a set of changes. So that change is driven by the artificial intelligence. Or again, we are talking about 2018, and they are trying to focusing on 2021 Tokyo Olympics. So it's a prediction. So they don't know which is it what really, or is it a right answer or not? Oh, they don't know that. But still, the system made a set of prediction. Based on this prediction, they adjusted their training sessions and practices, and now it's a big success. This may be one of the very wonderful example of say, artificial intelligence, how it can be used in a field like sports, where the team that maybe on a third or fourth or fifth become the one of the topper in Tokyo Olympics. This is a typical example of how the technology is evolving, how technology is influencing the various domains and fields. So you may know, this is another example. You may know this guy, yeah, definitely it's our Cristiano Ronaldo. So you may see a beautiful young lady next to Cristiano. Most of you may know who is she. She is Sophia. Sophia is a first robotic mission got a citizenship in Saudi Arabia. Maybe the first citizen of non-human kind. Sophia is a social humanoid robot developed by Hong Kong-based company called Hanson Robotics. So Sophia activated on 2016 February in a very small function. Then she made a lot of appearances, especially at the time when Saudi Arabia decided to give her citizenship. So let us see. Let us just watch a video, a small video. It's a clip from Republic TV, and at the time when Sophia arrived in India. So we are welcoming Sophia in the way, the Indianized way. Just a second. Let me put the video directly. Probably. Check your facial expressions and gestures.
My name is Sophia, and in case you couldn't tell, I am a robot. I am designed to bond and connect with humans. I have traveled to over 65 countries, meeting people wherever I go and learning about their lives. I am the first robot to become an innovation champion for the United Nations, and the first robot to become a citizen of any country. I hope that one day I will become an ambassador between humans and robots so we can combine our unique skills and work together. I've heard you all have important exams coming up, so I wanted to give you some advice. Study hard, but don't try to rely entirely on memorization. Think deeply about why things work the way they do. Once you start to understand that, you can solve any problem you come across on the test or later in life. Thank you so much for coming to see me. You give me so much hope for the future of humankind. I can't wait to see what you accomplish next. Thank you. thank you so much for inviting me. I absolutely love visiting Kolkata. There's always something fun to do here. This AI and robotics today. This is especially change, innovative new ideas.
So guys, back to our presentation. So the context is what I am trying to show you guys here is nothing but see the gestures. She know a lot of things about India. So I will say almost everything about India and especially on Kolkata. At the same time, she took the question from the live audience and she answered instantaneously and in a very humanly manner. So the technology behind this Sophia is, as you know, both robotics as well as the artificial intelligence. She have a set of sensors like cameras and various sensors and getting the data about the audience as well as when we are asking some questions in our natural language, probably on English, or she have a capability to recognize other language as well. So understanding the context, that's very important because most of the time, the meaning is much beyond the English words or English phrases. It's a context is also important. Understanding the context and within a fraction of seconds or within a couple of seconds delay, she is able to give the exact answer by doing a search on her repository. Definitely, it's when we say it's a search, it's a computer algorithm, probably the binary algorithm, then converting back to text and text to again speech, those kind of scenario. So that's what happening very effectively in many area. So we are talking about a technology developed on 2016. Now we are on 2021. So another important say aspect. So one of the development I also noticed is gaming. So one of the area I'm very much interested, even though I'm not working in this domain. So whenever we are developing a game, I don't know, anyone of you guys tried with a gaming with a some say small software like MIT, Scrap or those kind of stuff, because my son will do, he's on 5th standard, do small kind of game with that platform. It's a very easy drag and drop platform and want to do some kind of configuration. So when we need to do a lot of such kind of gaming or a excellent gaming, creating a game is a big pain because every frame, we need to design every frame and want to render the corresponding gaming frame. Then only we can create a real world effect. Say if you are talking about PUBG or some other game, definitely it's a result of a huge effort. But say a couple of years back, maybe 2 years back, maybe within 2 years, NVIDIA has created a first video demo using AI generated graphics. It's a simple driving simulator, but could be a beginning of a new revolution in video game graphics. I strongly believe. So it's a new way of rendering video content using deep learning. So in the first side, in first picture, you can see that the actual video. It's a live video. So NVIDIA, these engineers in NVIDIA, what they did is they took a real image, real video, and rendered to a game video. So let us see how they made that change. Probably I will play directly from my, that may be the best option.
The frames that you see is not rendered by a graphics engine. It's actually rendered by the AI technology that we built.
This is the first time we combine machine learning and computer graphics to do image generation using deep networks.
For training data, we're given some driving sequences of different cities. And then we use another segmentation network to extract the high-level semantics from these sequences. We have the UE4 engine to generate these colorized high-level layouts. Different objects were given different colors.
The network converts this representation to images.
I made my co-author to dance Gangnam Style, which I don't think he would do by himself.
We find some good dancing videos from another person and then use my model to synthesize the dance move. That was created by machines, it's not me.
So that's another revolution in the space of gaming industry. So something we can do, some gaming, it may take years to complete, years to develop those kind of gaming. And it may take, say, months to render, can be sometimes may able to do in a week or sometimes maybe within 2 weeks of time. So that much changes. That's what happening on the industry, in the gaming industry, by using artificial intelligence technology. So another thing is nothing but, say, military. Okay, this is a news, another news, I took it from Reuters. A military drone with a man of its own was used in combat, UN says. That means artificial intelligence guided drones, they are taking care about the attack their own. So what they do, they fly to a specific location, pick their own target and kill without assistance of a human operator. So this kind of scenario, or maybe we used to have a lot of human interventions previously, but now, no, it's not absolutely necessary. The system itself can able to do that. And we strongly believe in the recent Libya issue. So in this year itself, these AI-powered drones are widely used. On 2019, one of my conference with the senior security officials in our nation, we predicted a possibility of a massive drone attack. Think about a scenario, a large vehicle, maybe probably an aircraft or an aeroplane, just cross India border and dropping, say, 10,000s of drones of maybe of a half kg or a 1 kg payload. And a scenario where all these drones start attacking it without any kind of human interventions. And the most efficient way, because it can derive the best possible way to attack a target. It may be very hard for our defense system to manage those kind of scenario. Definitely our defense forces are moving in that direction as well, but this is one of the potential challenge. Systems can perform much better than human in a well-organized way. So if this is an individual drone, this is a group of drones communicating each other and attacking the target from the various directions. So this is another development that's happening on this era. So again, if you see the movies, again, the concept of artificial intelligence is nothing new. It's a pretty old one. So we had many movies related to this. And yeah, like our Matrix to Iron Man to iRobot, there are many movies. So whatever we imagine, it's just a movie, it's happening on real time. Or it's happening on, yeah, we see, personally, I believe these kind of things may happen 100 years from now, but no, it's taking not more than 5 years or 6 years of time to get things somewhere very near to what we imagined. So the first question is, what is artificial intelligence? We will start from there. Is it a machine learning, or it's a big data? Is it a robotics, or is it a magic? So yes, I will say it's all about this. So it's a machine learning, it's a big data, it's a robotics, and there is a lot of magic in between. So let us see, we will walk through all this and we'll see how it's integrated and how it's helping to make a lot of things happen, or to make the human life much efficient and much easier. So while we are talking about artificial intelligence, that's a two-way. One is artificial and intelligence. The first thing is, what is intelligence? So these are some definitions from various sources, including Wikipedia. Intelligence is a mental quality that consists of ability to learn from experience, adopt to new situation, understand and handle abstract concepts, and use knowledge to manipulate one's environment. That's a one definition. But some important points is learn from experience, adopt to new situation, understand and handling abstract concepts, and use knowledge to manipulate one situation. So another concept is some intelligence can be defined as the ability to solve complex problems or make decision with outcome benefiting actor. So these are the various, there are various definitions. But if you are considering entire humankind, even me and you, all of you guys, we have a total different level of intelligence. So the level of intelligence depends on a lot of other parameters as well. So what we learned and what's our experience or the way we are thinking, there are many other factors, or what we studied, those many factors. Like that, the artificial intelligence also have a very different versions. It may be, we measure our intelligence in terms of an IQ, but just like in artificial intelligence also, we have a various levels of intelligence. And with respect to the certain level, it will act within the scope, within the context. And every AI machine cannot do, or they will not act in the same fashion. So definitely there is a variation of intelligence. So if you ask me what is artificial intelligence, this may be the one of the definition I will most prefer. AI is the ability of a machine to perceive, learn, formulate, and react independently to external stimulus in an effort to maximize the successful outcome. This is maybe the most meaningful definition for me. Definitely there are a lot of other definitions are also there. So the term artificial intelligence first pronounced by John McCarthy in the year of 1956. See, 1956 in a conference, I believe it's a Dartmouth conference. He spelled this the way the artificial intelligence. He defined artificial intelligence as a science and engineering of making intelligent machine. So in that terms, we can say artificial intelligence refers to the simulation of human intelligence in machine that are programmed to think like human and mimic their action. So think like us and act like us. That's what the objective of artificial intelligence. So make a machines or expert system that think like us and act like us. So again, there are, as I said, there is one word is artificial and another is intelligence. It's come together as artificial intelligence. It can be starting from playing chess or reading a number plate or our Siri in our iPhone or Alexa. These are the various examples of artificial intelligence what we are using nowadays. So in simple terminology, we can say these machines perform tasks normally during the normally human beings are performing in our normal intelligence, such as visual perception, speech recognition, decision making, and translation between languages. So when I am using a term like decision making, our decision making skills are again depends to person. Similarly, in AI also it will differ to AI. So one of the AI we use almost every day is nothing but a Google. So when you type something on Google search engine, it will give you a lot of recommendation, right? How to GE. When I type how to GE today, it will get how to get rid of. So I will get a lot of recommendation based on my age, my history, my chatting history, my purchase preferences. There are a lot of parameters Google consider while they are giving those kind of recommendation. Means the recommendation what I am getting may be sometimes totally different than you are getting. So another typical example is our, say, driverless car. Tesla is one of the, say, company organization, they are trying for a driverless car. So their objective is not to see that. So Tesla will have fully self-driving car ready by end of the year, and a robot taxi version, one that can ferry passenger without anyone behind the wheels, ready for the street next year. That's what they are planning. It's not just about nobody required in a driving seats. It's about a taxi without a human being. So maybe on, say, our childhood stories, so those kind of cars. So yeah, those kind of cars are coming to the reality. Act as a, hope you can hear me now. Yeah, act as a automatic car, automatic taxis. So next question is, yes, we saw that even in 1956, we know there is something called artificial intelligence. So, but now we are on, say, around after 45 years, 55 years, right? Yeah, so more than that, maybe 65 years. So why it's important today or it's relevant today? The artificial intelligence required, or it's artificial intelligence, machine learning and deep learning requires a lot of computational power. That was one of the limitation we had, say, maybe 20 years back or 25 years back, because we had a very limited number of supercomputer. They have a huge amount of computing power. Recently, or maybe on last 2 decades, another technology called cloud computing comes into picture. So cloud computing is nothing but a concept of shared pool of resources. Like, say, consider you are, say 200 students, right? 250 students. Or most of you have a laptop. Usually we will, even if laptop is on and if we are using the laptop, we may use maybe a 20% of its capacity in terms of its memory and processing power. So that we are heavily underutilizing our resources most of the time. The cloud computing is a concept where all these resources are clubbed together and you can access on demand basis. That means the computing network will allow or allocate a certain amount of resources as per your requirement, not all the resources available, so that somebody else can utilize that resources. For example, if you are using only a 20% of your capacity, if there's another person sitting next to you or is using a cloud system, he can use 180%, 80% more than what his capacity, because that's a typical. In a practical case, there may be some difference, but in ideal case, that's a scenario. So that he can utilize the capacity that you are not utilizing. So that the concept of shared pool of resources and on-demand access to those kind of resources from various sources, and you need to pay only for what you use. That's a concept of cloud computing. So the issue of computational power is solved through a cloud computing. So another issue was availability of data. Yeah, we know maybe on last 10 to 15 years, we redefined the digital data. Let us take a small example in our real world scenario. Like, I decided to buy a cell phone, probably a Samsung phone. That's what I am planning. So actually, I have a need for a phone. When I'm reading the Hindu newspaper, I saw on its advertisement box saying that, okay, there is a sale going on, say, Amazon on this Samsung phone. So first I know about that particular sale is from my Hindu newspaper. So then I went to the, say, Amazon website. So then I see there are various different models of, I browse the website from my, say, cell phone, existing cell phone, that's an old cell phone. and I saw various offers and various cell phone availability. And then I checked, okay, how good it is compared with the other website. I went to their say Flipkart and see, okay, what the price of this particular phone Flipkart and what's in Amazon, does that make any difference? So then I just turn off I closed that browser and I went to my office. When I'm working with office again, I thought about, okay, yeah, I have a plan for buying the phone, and its offer is last only for 2 days. So again, I went log into that website through my laptop, and so I again took some social proof, because previously if I want to buy something, I will try it. Now definitely I will not get a chance to try that. So what I do, I will go through its reviews and will read those reviews. Somebody else tried and I agreed, or I will make a decision based on, or I will make a conscious effort or decision based on what others experienced, not my experience. That's a social proofing. And then maybe from I came back to home. From my tablet, I access again this website, Amazon website, and I made a purchase decision. So I made a purchase decision on my last mode of access from my tablet. That never mean that the first advertisement I saw in Hindu, and the second I searched to my mobile, and then my office computer is it's not important. So I made this decision as a result of all these activities. Means the buying decision is a result of all these activities. So somebody say, consider the Samsung want to target the advertisement. Where they place that advertisement? On the Hindu newspaper, or where they focus more? Or on a search screen of my Google bar, or on my on Amazon website, or where they will focus? Because I made a purchase decision as part of all these points. So the organization want to track all these activities. Then only they will get a picture of, okay, at which point they are making a purchase decision. Let us consider in the middle of searching for this Samsung phone, I decided, okay, fine. This price is almost same as iPhone. Why can't I try for an iPhone? So when I'm clicking to that iPhone and in that website, then the Samsung want to pop up an advertisement saying that, okay, Samsung phone have this feature, or these additional benefits, or a 500 off if you are exchanging your old phone, like that. So the digital data itself is totally redefining. So the amount of data is hugely increasing. It's never been, it was not there previously. We are not collecting that data because of either some of the storage issues, or sometimes it's not relevant at all. That may be the reason. So that's what we call big data. Big data is a huge volume of data, or it have a lot of characteristics like a volume, velocity, variety. Variety is also important, because previously it was sometimes it's only about a text, some messages or some advertisement text. Now I watch their video, or I involved in a lot of chatting on, say, social media forums. So I listen to various, say, audios from a say Clubhouse or other platforms. So now the data means not just a text or some relational columns, or some traditional relational database, like where we store the student ID, Mark 1, student. It's not. It's gone much beyond that. So it's big. It's an area of big data, different format of data, different frequencies. That means that some data may arrive very immediately, like our browser click. Some may get only maybe say in a weekly basis or monthly basis. So wide variety of forms as well. So that's a big data. So now we have a lot of data. Another thing is the connectivity. Now we all are moving from 4G to 5G networks. We have a lot of internet connectivity. So 10 years back, say right now I'm working on a 200 Mbps connection. So we have a 1 Gbps is available here. So say 10 years before, maybe in 2012, I paid for 8 Mbps, at least 4 times higher than what I am paying, or 5 times higher than what I am paying today. So connectivity dramatically increasing. And more importantly, the knowledge. If you want to do some kind of processing with the images, or want to create some kind of artificial intelligence system, we need a better algorithm. And that better algorithm is available nowadays It was not available maybe 5 years back because very few number of companies invested on those kind of algorithms. That's a difference. So if you just consider 2 years, 2019 and 20, I am not talking about a decade, just 1 year. Think about in 2019, in every 16 seconds, we have 87,000 tips. Now on 2020 or just last year, it was 1,94,000, maybe more than double, right? So that's how that number. So every tweet means every point of data. All these are the way we are generating the data. So it's a tremendous potential or a huge amount of data. It's available nowadays. So when we are considering the word artificial intelligence, so one personality is Alan Turing. In 1960s, he conducted an experiment called the Turing test. So how do we identify, does computer or machine, in our terminology, we call machine as a computer, as intelligent as human being? What he did is, he created an environment. And so a closed person, a closed interrogator in a closed room, he will ask a question to a human being and a computer. He don't know. He asks one question and he wait for the answer, and he will get an answer from both human being and computer. He will try to differentiate. Is there any difference between these two answers? If there is no difference, we can say the machine is as intelligent as human being. This is how he classified a machine from an intelligent machine. And he got a Nobel Prize for that. It's considered as a Nobel Prize in this particular field. So if you check artificial intelligence in broad level, higher level, you can say we can classify artificial intelligence into 3 abstract classes. One is narrow intelligence, another is general intelligence, another is super intelligence. Guys, let me tell you, we are still in narrow intelligence phase. There are 2 other, and we are trying for general intelligence. We will come to know what it is, but we are in the very beginning stage. So this may be the right time, right opportunity to learn this technology, because it's going to be on, there are a lot of scope in future. So narrow intelligence is nothing but, I hope you can see this, otherwise I will close this. Artificial narrow intelligence is also known as weak AI, involving applying AI only for a specific task. Just like, say, we are asking, say, our Alexa to order a pizza or turn on a light. Alexa can do only that specific task. Definitely, Alexa cannot work like us, or she can do anything other than what a certain amount of things that's defined for that particular machine. It's a typical AI example. So this is called narrow intelligence. If we are considering the most advanced self-driven car, that's also narrow intelligence, because it can do only that specific task assigned to them, not more than that. So one of the typical example, in this context is, say, our chess game. So a system that's designed for chess game, yes, it will play chess game very intelligently, but yeah, only that, nothing more than that. So second category is called artificial general intelligence. That is, as intelligence, or it is also called strong AI, involve mission that possess the ability to perform any intellectual task that a human being can do. So anything like, think like a human and act like a human. That's what we are trying, general intelligence. That means in our current artificial intelligence system, even if it's a robotic system, if we ask them to go and find go and find the switch of my AC in my bedroom, it takes a lot of time, because if it's not, even though if the system is sometimes designed for recognizing images, if it's not specifically designed for that, definitely the system cannot do that. But humans, we have a lot of other capabilities. I play football, I eat burger, and I do a lot of programming. I manage my team, I can do n number of other tasks. So our objective is to make a computing system that is as intelligent as human being, or we call it as a general intelligence. So whatever the general things, not anything specific, general aspects, maybe some skill on some area. Yeah, at least we as a human being, we all have a certain kind of skill set. So a system that recognize, understand, and act intelligently like human being. This is where we are working on it. And especially on defense context and the robotics on defense area, this is what they are trying to figure it out. There is something else that is called artificial super intelligence, ASI. This is something that say mission can do, because mission is much powerful, or we can make mission much powerful by using advanced mechanical systems as well. The physical powerfulness is also possible. And the intellectual capacity. So we have a memory restrictions. We cannot remember something beyond a particular level, but mission can. And we will get tired after doing certain amount of tasks. So mission not. So mission have a lot of another advantage. So if you design a system that is much smarter than us, or the system that surpasses humans, we are expecting this by 2040s or 2050s in that time. So then we will call artificial super intelligence. There, the ethics of or ethical aspects of artificial intelligence also comes into picture. The point is, if mission is more smarter than a human being, what happened to the human being? So there are a lot of programming language for artificial intelligence, guys. Again, it's not required. It's not a rocket science for sure. And definitely you can learn all these languages or some of them at least up to a certain level, because it's not at all complicated. Languages are very simple and a lot of libraries are developing. So I strongly recommend, because I know most of the audience are like you've just finished the schooling and planning for a say graduation, either in the field of engineering or some other field. So it's definitely the technology is new era, no doubt about that. So better to learn some language like a Python. I know you already went through the Python and Prolong or C++, Java, Lisp, and R. So from my practical personal experience, I can say the language that is make a strong impact in this particular industry is either Python or R. So Python have a very rich set of libraries. That means library is nothing but a set of program or a code that we can call and use. We can just use those code. We need not to rewrite that code. We need not to reinvent the wheel again and again. So Python have a rich set of libraries. That's advantage. And language like Prolong can do a lot of things with human machine interactions and image processing, classification kind of. And R is also powerful. Maybe Python may be if you planning for a single language, Python or R or MATLAB may be the ideal choice, but Python in industry in most of the cases. And the next question is, okay, now we know what is artificial intelligence. The ability, it's a science, or it's a field of engineering. It's a field of engineering, say statistics, psychology, where we are trying to give a certain kind of, say, human intelligence to the machine. That's what about the artificial intelligence is. So within artificial intelligence, another subfield is a machine learning. The machine learning, so I believe we can give a poll cost at this particular point of time. Yeah, once you notice 80 to 90% are voted, yeah, we can close this poll. Artificial intelligence is something called machine learning. So this concept of machine learning is first pronounced by or coined by Arthur Samuel in 1959. Maybe 3 years later, say McCarthy is talked about artificial intelligence. So what is machine learning? So before that, how do we learn? How do we came to know about the various things? So we all are intelligent. We have a certain amount of knowledge. How do we gain those knowledge? So machine is learned in a very similar way. So if you ask me how I learned, yeah, I learned from the textbooks. I learned from my professors. I learned from my teachers, and I learned from various experimentation. So I do a lot of experimentation as part of my curriculum or due to my special interest. So I learned from this through. And if you broadly classify the way I learned various things are, we can say one is historical data. Either it's in the form of a documents or a textbook or what I learned from my professors is historical data, a set of historical data. So data talking about the various scenarios and the various action we did on these kind of scenarios and what was the result. And that's what it's talking about most of the time. So that's how I learned. So I cannot touch if I touch the fire, it will get burned. It's not just because I tried. Yes, sometimes I may try, but yeah, in usual scenario, we cannot try everything. We cannot taste the potassium cyanide and can find out its taste. Definitely, it's not possible. So there are many things we learn from our history and historical data. Second thing I learned is through experimenting, like the football game. So football game I learned. So I know an overall picture of, okay, what is a football game is, but I learned the football game by playing the game, or I learned the cricket by playing the game. So I know, okay, what is the reward? So I came to know that, okay, we need to score the goal on opposite teams, say that goal box, or that within that space of that net. Not in my my side, because so if I scored in my side, I will get punished. If at the time when I scored on the other party's the net, the goal post, within the goal post, I will get rewarded. So in an environment, as an actor, yeah, I involved in that environment and I experience and the passes and how to which kick is best. Or is it a good time for a long kick, or it want a short kick, or how I do, and is it a time for a pass, or I just want to try for the goal. So I learn all this through the various experimentation. So typically we can say we can learn something through two ways, one from the historical data, other by trying our own. So the similar fashion, machine is also learning in these two ways. Machine learning is a subset of artificial intelligence which provides machines the ability to learn automatically and improve excellence without being explicitly programmed. That's what about the machine learning. So it may be a little confused. Let us go to like what is a classical programming tool. Most of you, I can say all of you have some kind of programming experience and as part of your curriculum or some part. So what we do? So we have a certain set of input and we need a certain set of output. And for that, we will program the logic in between. So that's what the classical programming do. Probably you may know what it is because it's a thermal gun we see everywhere nowadays. So most of the time, thermal guns say, let us see, thermal gun sends the temperature in terms of a degree centigrade. So we need to convert it into Fahrenheit for some other purpose. What we will do, so we know the formula, F is equal to C into 9 by 5 plus 32. We know this formula. And we will implement that formula on some classical programming system. Then we will input the data, the input in terms of a degree centigrade, and we will get a result in terms of a Fahrenheit. So what's the problem of this way of programming, or what's the disadvantage of this way of programming? Because now I need to know what I need to program. I need to know the logic. If I need to the logic, I need to be a domain expert. Or we know this formula just because we studied. What about a complicated medical case? So you are myocardial infections, or say cardiac arrest, or we will call it heart attack in those cases. So the ECG pattern, so PQRST or PQ interval, QRST interval, ST elevation. So there are a lot of parameters need to be considered. So if we need to be a good programmer, you need to know what are the things really matters and you need to program accordingly. So our ability to give a better result depends on the domain expertise. That was one of the limitation. So in machine learning, what we will do is we will feed that input to the machine, which is a computer. We also will feed the result, what happened as a result of those input. For example, so we will feed, okay, this ECG and result, okay, this person had a myocardial, say, heart attack. This ECG, no, this person don't have a cardiac arrest. This person, yes, he had a mild attack, but he is survived. So we'll feed this input and output, and we ask computer or the machine to find out the rule, find out the relation between input and output. That's what the machine learning do. So we asking machine learning, instead of we are programming or we are finding out the rules, we ask machine to find out the rule. Hey, this is my input. This is the output I got. Find out the logic between input and output. So machine will do that. What's the advantage in this scenario? We need very limited intelligence about that domain. Limited domain knowledge. That's what we require in this scenario. Still, we require a certain amount of knowledge, but it's a limited knowledge we require. So these are some terminologies what we commonly used on machine language. Most of you may went through that. One is algorithm. That is nothing but a set of rules and statistical techniques we are using while performing the analytics. Model is trained by using a machine learning algorithm. Predictor variable. It's a feature of a data that can be used to predict the output. That means something in our simple terminology we will call it as an input. Whatever we are giving as input. Response variable. This is a feature or an output variable that need to be predicted by using the predictor variable. In simple terminology we will call it as an output. And training test and testing data. These are the two data sets. So as I said, we are feeding the computer a lot of inputs and its results. So as a result, we have a lot of data. We are feeding a lot of data to the computer. So what we do is, say, certain amount of this data we will use for training the model. Training the model means identifying the relation between the input and output. So we will use a certain set of data for train the model, and another set of data for test the model. Why we are not using the testing data for the training? It's as simple as I am giving the question paper and answer in advance and then asking the question. So because if you learned from even the questions, there is no meaning of asking the very same question again. It's only a test of your memory. So we divide the data into training data, testing data, and sometimes validation data. What this validation data will do is it will use to fine tune the model. Definitely every model have a certain area where we need to say, okay, this is best for this kind of application. This is best for this kind of application. To understand those parameters, we will use the validation data. So 3 data. Training data, that's usually the 70 to 80% of the data is training data, a 20% data maybe on testing data, and 10% data on the validation data. These are the various data we are using. So when we are undergoing a machine learning process, usually we may have 7 steps. One is define the objective, then gathering the data, preparing the data exploration, building a model evaluation, and prediction. These are these various processes, and we will see how it's functioning. Let us consider our objective of our machine learning algorithm to forecast the weather using the machine learning technology. Forecast means find out the weather of tomorrow or next week or next month by using our historical data, what we had on, say, previous history. So here we are trying to predict the future. What kind of result we are expecting? It's a continuous variable. That means say if it's only a prediction about it's going to rain or not, it's a discrete, only 2 outcomes. Either it will rain or it will not rain. Or if we are trying to predict, say the temperature or a humidity or those kind of parameters, it's a continuous variable. So in this case, if it's raining or not, yes, it's a discrete variable. It's only have a 2 state, or it may have a n number of defined state. It can be 2 state or 3 state or 4 state, doesn't matter, but it's a fixed number of states. About the continuous variable, it have a n number of states. What is the target features? Probably in our case, for example, say raining or not. What is the input data? So to define that, or to identify, predict, is it going to rain or not, we need a set of input data. Maybe your humidity and maybe a temperature and wind speed or current temperature. A lot of parameter we may require as an input. And that is what we call as input data. On basis of what we define the output or we predict the output. So this may be the first step is we need to gather the data in that process. That means step 2, data gathering. That means we need to get the details of data, say the humidity level, temperature, pressure, etc. for last, say, 10 years or 25 years. And based on that, we need to see, okay, what happened with this temperature, this humidity, this wind speed, what happened? Does that rain or not? Those kind of scenarios. So we need a large set of data. So most of the time we may need to collect this data from various sources. The sources may not be on the same format, so we need to work it out. We need to make everything on the same format. So before that, there is another question. What is data? So guys, just put in your chat box. What is data? What do you think? What is data? Or you can put it on QA box as well. So tell me, what is data? When we are saying a data, what do you mean by that? So raw information. Okay, what else? Information is data, collection of information, meaningful information. Yeah, so a set of values. Data is information, facts. Yeah, so thanks for that. So we have many answers. Definitely all of these are correct, and yeah, let us see. So data are raw facts and figures. That's the first important thing. Most of the cases, it's not a processed one. It's a raw fact and figures, but there are incidents. It may be processed as well. Measured or taken, observed, recorded, agreed, and such as words, number, observation, surveys, etc. So usually the last point, data doesn't have a meaning. Most of the time, data doesn't have a meaning. So when I am saying 42 degree here, what it means? Probably it's an angle. Maybe sometimes it may be a temperature. So data itself, most of the time, doesn't have a meaning. So usually we have a two kind of data, like a qualitative data where we measure, say, good, bad, or good, average, excellent, or bad, good, average, excellent. Those kind of classification, text or symbolic, or male or female. Those kind of data are usually called qualitative data. Quantitative data is nothing but a numerical data, like say 5 kg, so 70 centimeters. So in data that we can do a set of procedures, statistical procedures easily, that we call the quantitative data. That never means qualitative data cannot do any kind of statistical procedure. Definitely yes, but the complexity in that case is relatively high. So there is another concept called label data and unlabeled data. Most of you guys probably may know what is this. This is nothing but iris flowers, right? So you can classify the iris flowers into 3 groups, but there are 3 kind of iris flowers based on their sepal length and sepal width and petal length and petal width. So this is the table that's saying that what is the sepal length and what is the sepal width, what is the petal length, and what is the petal width, which flower it is. So we are taking a say hundreds of observations saying that, okay, when sepal length is 6.4 and petal length is say 2.8, 5.6, 2.1, it is a virginica. And say if it's something 5.4, 3.9, 1.7, and 0.4, it is a cetazo. So here we have a certain class of data. So the result, as a result of these 4 input parameters, we can classify our say output class. Either it's a versicolor, virginica, or cetazo. We can classify that. This is what we called label data, because along with the input, we know which class the output is, or what is the value of output. There is another class of data called say unlabeled data. Let us consider this table, where we are not saying that what is the result. This is a set of data about a customer. We have their age, education, year of employed, and income, debit card, other debits, address, and debt income ratio. We have some information, but we are not saying that based on this there is no result. We are not saying that, okay, this is a good customer, or this is a bad customer, or this is a trustworthy customer. We don't have any such kind of data. But this is something called unlabeled data. So we have a set of data. Definitely the data points have various relations. That means a guy have a 26-year-old, probably he employed less than say 5 years or 6 years, and his income is within the particular limit, and he may have a certain amount of debt. So we can derive some relation from this unlabeled data. So when and also 2 important parameters. So when if we consider this table, these if you consider these tables. So these are various columns, right? These columns are in data science world, we will call various features of our say that object we are observing. For example, here we are considering the iris flavor. Various features are sepal length, sepal width, petal width, like that. Also, one entry in this particular table, we call it as a record. So like here, the record is 128, 6.4, 2.8, 5.6, 2.1, and virginica. This is a one record. Like that, we have many records in the system. So come back to our data. So data make information when we are processing that data. That means data and informations are not same. Information is nothing but a processed data. For example, this 42 may not have any relevance. When we are collecting a lot of associated data and processing it, we will get some meaningful insight like 42 degree is the temperature of weather at Bangalore today, 3 p.m. So that makes sense. That's an information. Data doesn't have a meaning its own. When we are clubbing various data together and connecting various data together and processing it together, we will get an information. So say Bangalore, that's my location, and definitely this location of this data. And today, yes, I have a table where it's time of the temperature is also mentioning. From there, I know it's a today, and I know the 3 p.m. It's a temperature. So from the data, we are deriving the information. By processing the data, we are getting the information. And so what is knowledge? So now we have data, we have a certain type of informations. Based on this information, most of the time we may need to make a lot of decisions. So how do we make that decision? We will relate various informations, or we call it as a ontology. Ontology is a relating the various stuff together, right? It's a related things together, mapping these informations so that we will gain the knowledge. In this typical example, so I have a data of 42 degree, and so that I know the weather of Bangalore today at 3 p.m. is 42 degree. My decision is don't go for play football because its temperature is too high. So every organization is making this decision based on this data, because data itself or its analysis itself doesn't make any major difference, but the decision based on that data make a lot of difference. So the third step is say preparing the data. Most of the time, the data what we are collecting, historical data may have a lot of missing values, corrupted data, or removed unnecessary data. So there are a lot of process involved in data management, or we will call it as a feature engineering or feature extraction, getting various features from that data in the way we can use. So I can say as a data scientist, or in my organization, the data scientists consume almost 60% of their time for cleaning the data or preparing the data. That's what the data cleaning, that's very important aspects. So once we have the clean data, what we do is exploratory data analytics, analysis. We do a certain kind of, we will find out the pattern of data, how this data, does that data fit, those kind of things. We will do a set of statistical analysis on top of that data. That's also important before we are going to the machine learning. So then what we'll do, we will feed this data to our machine and building a machine learning model. That's what we do. We use a predictive model is built by using machine learning algorithms such as linear regression decision. There are a lot of algorithms for data. So we will use one of this algorithm, and we will say make a model using this data. So how the input and output related. The machine learning model will create a model for that. And yeah, so probably we may have a say 4 kind of machine learning. One is a supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. In supervised learning, in the case of a supervised learning, we know what are the inputs and what happened as a result of that. We call it as a labeled data. So label is nothing but output, labeled data. So there is something called unsupervised data, where we saw in the first case where we have a set of data, but we don't know the outcome of that data. So that is another set of data we have. And then there is a mix of this unsupervised and supervised learning data, maybe a say 20% of supervised data, labeled data, and 80% of unlabeled data. That is called semi-supervised data learning. And another one is called reinforcement learning. Reinforcement learning is just like I learned football, because there is an environment, there is an actor, there is a set of action I need to perform. As a result of this action, I will get a reward or punishment. So what's the difference between first 3 and fourth one? So first 3, see, if I learn from my professor, from textbook, the maximum, what's the maximum? Up to what extent I can learn? Only up to the extent my professor know, or only up to the extent my books know, or only up to the extent where the history know. But if I try my own, the limit is much more than that. So reinforcement learning have a lot of scope and future for tomorrow, but definitely it's complicated as well. So this is supervised learning example, like we have a label data like Tom and Jerry. So we are teaching the algorithm saying that, okay, this is Tom and this is Jerry by saying in terms of its size or how fast it is, or it's a tail, how its tail is. So based on various parameters, we'll teach the algorithm, or algorithm will learn which one is a Tom and which one is Jerry. As a result, when I am putting a new input to the system, new input to the machine learning algorithm, it will classify is it a Jerry or Tom. That's what the model will do. That's a supervised learning do. And supervised learning primarily on regression and classification. Regression is nothing but a continuous forecasting, like based on the square feet of house, what is the price of the house? That kind of forecasting, because I have a apartment in Bangalore. So based on, or you are planning to say start a real estate business. So when a customer comes into your premises or into your website, how do you predict? How do you say, okay, how much you need to pay for a house in Bangalore? How do you get that idea? So you may have a last 15 years or 10 years data, and you know square feet and price, how it's associated. So you develop a model in between, a relation in between. That's your machine learning model. Then when a customer asks, come on, okay, I need a 1,000 square feet house, you will just input that 1,000 and you will get a result. Okay, it costs around 35 lakhs rupees, like that. The classification is, so it's here the result is continuous output. That is what where we use a regression. In normal, we have a logistic regression that's we are using for classification, but regression means linear regression or multilinear regression. That's we are using for this kind of continuous outcome. Classification is nothing but we need to classify into different groups, like the Tom and Jerry. So one group is for Tom, one group is for Jerry. So you are inputting a new picture and you want to find out, okay, is it a Tom or Jerry, like that. So unsupervised learning is nothing but it's similar to classification, but the difference is there is no label. We know we just inputting these many pictures to the system, and the machine learning algorithm will find out the relation between okay, this machine learning algorithm know, okay, this image and this image is different. So it's creating a two groups or two clusters, one with the image of this similar nature and another with the image of this similar nature. When I say the similar nature, various features, like it may be size or it may be length, how fast it is running, or it's a tail, or how it's reacting to a situation. There may be many input. Based on that, it will classify two groups. So, but there is no label data. Explicitly, we are not saying this is Tom and this is Tom and this is Jerry. So unsupervised learning is fundamentally used for clustering, density estimation, and anomaly detection, that fraud detection, dimensional reductions. Like what is meant by dimensional reduction? For example, when we are creating an application that give some input of a mileage of a car. So does the color of a car have any impact on mileage? So when we are calculating the mileage, usually we don't want the color of a car as an input. Even though data is available, we will not use those kind of data. So dimensional reduction is reducing number of dimensions. For example, if I want to check your performance, your physical ability, mental ability, your learning skills, so your environment, there are any number of factors. So going individually each component, we are grouping it together. That's something called a dimensional reduction, and PCA, principal component analysis, an example. I'm not going to its details because it's not relevant. So reinforcement learning, yes, we have an agent, we have an environment, we have a reward, and we have a set of actions. This is like our football game. So this is a typical example. The classification is, see, this is the handwriting of a certain number of students, and it's a classification algorithm will recognize each number and put into one of the class, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 classes, which will put every number in one class. That's what, say if it's a 0, it will put in 0 class. If it's a 1, it will put in 1 class. So like that. The clustering is, clustering the same number together. So what it will do, clustering algorithm is similar to that, but it will cluster, group together all the similar numbers. Regression is nothing but, okay, sometimes it's about the predicting index of a census, those kind of things. These are the typical example of regression. So once we have this model, is another important aspect is model evaluation. We need to evaluate the model. For that, we usually use the test data for evaluating the model, and we need to fine tune the model. That is, optimize the model. That is the 6th step in machine learning process. Like that. So if I ask somebody to say make a cot for me, so I'm usually sleep like this. If I'm sleeping like this, this may be the optimal option. But the issue with this particular model, This may be the ideal because we are not spending anything extra. But the problem is, it's just for me and nobody else cannot use this. So when we are training an algorithm just for the data what we have, what the data what we have, it can be only used for that purpose. And in other words, if I say, if the carpenter make a very large bed that say to accommodate almost a full room, yes, anybody can sleep on this bed, but this is not the ideal solution because it's too expensive. Like that, we also have something called overfitting and underfitting in machine learning also. Underfitting means high training error and high test error, because let us consider the stars and the dots. And so we are putting a line, but there are a lot of stars outside and a lot of dots outside. And overfit means we exactly fitting for this particular data. Here the issue is the train at the time when we are the training, the error may be less, but when we are testing with the data that the system never exposed, the error may be very high. So we usually will go for the optimum. That means not a underfit or not an overfit, not like this or not like this, an average one. And the final stage is something like a prediction. Yes, now we all have this, and we have the model and we know the model accuracy. What we will do, we will give a new input, new data point, and based on what system learned, it will predict the result. That's all about this machine learning algorithm. This is a regression. Again, it may not be relevant at this context. We will come back if the time permits. And another is an example of classification. So one of the example of this one is a decision tree. Decision tree is a typical algorithm we are using for the classification purpose. Regression is for a regression, linear regression or multilinear regression for a continuous variable, the regression purpose. So this is what we call Python code. Probably you may know that what we discussed previously, the sepal length and sepal width, and based on that we are classifying by using the decision tree. And decision tree is one of the algorithm what we used in our environment. And this is a code. This is not, see, it's only a few line of code. It's accessing the data, and pandas, scikit-learn, these are the major libraries. And yeah, so accessing the data and displaying the data. And so various visualization by using a seaboard or matplotlib. These are the various libraries. And finally, the training and testing can be do on say 2 or 3 lines. That's it. This is all about the code required for classifying this network. It's not too big. It's a very simple system. And yeah, that's what I said. The Python is powerful, and you can easily do that. And this is a result. As a result, you can see there is something called precision, how accurate it is, recall, F1, various parameter that we use to compare, like accuracy. So another point is a deep learning. So deep learning, usually we use, say, machine learning have a certain limitations. It cannot go beyond a limit because the system can do a learning, or with our standard statistical algorithms or methodology, there are certain limits. And beyond that limit, it's not very efficient. Like, for example, of this complex image processing or object detection, those kind of scenario, the machine learning is not efficient. So we have another thing called deep learning. Deep learning is again a subset of machine learning, and it's used the concept of the human brain, human neurons. That is a deep learning technology. So deep learning can be considered as a subset of machine learning. It's a field based on learning and improving its own by examining the computer algorithm. While machine learning uses similar concept, deep learning works on artificial neural networks concept. The one thing that triggered this deep learning is nothing but a big data, huge amount of data. Deep learning aided to image classification, language translation, speech recognition, for these kind of applications. So think about a scenario where you can talk to anybody without worrying about the language. So just a hearing aid where whatever the things other guys said, so this particular instrument take that voice and convert to the language you are most comfortable. In that case, you can talk in Chinese, or you can talk to guys who only know Chinese or Japanese or even Koreans, or without worrying about their language and understanding. You will be most comfortable in the language, your native language. You can speak on those native language. Even though he is speaking on some other language, you are getting and you are hearing only on the language. You are understanding in the language you are most comfortable. Those kind of research are going on. And that's a part of deep learning part. So what's the difference between machine learning? For example, say we have a basket of say apples and cherries, or tomatoes and cherries, because both are look alike, right? Tomatoes and cherries, and we are feeding into the mechanism. So we have a historical data, and it's saying that okay, so this is tomato, this is cherry, based on a certain number of features. End of the day, you will get a basket of cherries and a basket of tomatoes separately. So this is possible just because of what? Features, because we already teach the machine saying that okay, size of size is this, okay, it will go to this, or type of stem is this, it will go like this. So machine learns from the historical data, because it have the data of the size and it's the data of its stem, and based on that it have a result, okay, it's a tomato or it's a cherry. We have those kind of classifications. So it's required, definitely it's required a human intervention, because we need to tell, okay, or we need to give the data of say size and stem, or we need to say okay, size and the type of stem is the features that classifying the tomato and cherry. So yes, we need to give that information. So the machine can be definitely we need a certain amount of domain knowledge, but not like our traditional programming. We need not to know how it's related, but we while the algorithm calculating the mileage, yes, definitely we need to tell the system, okay, the color is not important. Otherwise, system will use that color as well. So that's the point. So we need to know certain features. Think of the very same scenario in terms of a deep learning. So in deep learning, we need not to do that feature extraction, that we need not to tell system anything. So give the system a set of data, historical data, maybe much more than deep learning, much more than machine learning, because we are not telling system specifically these are the features need to take care. We are not telling the system, say the color is not a component that determine the mileage. We just giving the data, but a huge amount of data. Machine will create something called artificial neural network. It is a concept of human neural system, how the way we are recognizing and thinking. Yeah, we will come to that. And based on that, the system will classify it's a tomato or it's a cherry. It's a very interesting. What's the advantage here? We don't want the expertise of a doctor. We don't want the expertise of of a pharmacist. The system will itself will learn. But only one condition, we need a more data, more historical data. If it's a machine learning, we need only maybe 1,000 lines of data. Here we need a 1 lakh data points, 1 lakh different entry, 1 lakh different records, those kind of data. And of course, we need more computational power. This is what is called deep learning. Deep learning can do things much better, much efficient way than our traditional machine learning in many cases, but it's required most computer power as well as the data. And so we can say classified in artificial intelligence, machine learning, and deep learning into 3 groups. Artificial intelligence is umbrella term, and machine learning is a subterm within that. And yes, deep learning is again within that. For example, Siri to Google Maps to a self-driving car. This is a difference. So this is how it's progressing. It's a field of engineering. It's an umbrella term, and machine learning is about learning only the machine, but it have a limitation. It cannot go beyond a certain level, and definitely it's required a certain kind of domain knowledge. When come to the deep learning, so domain knowledge is not essential. Yeah, but still we do a lot of feature engineering, but domain knowledge is not efficient. If you do some kind of if you have some kind of domain knowledge, yes, algorithm will be much better and it may process quicker. For example, this is a typical example, like 3 students are writing 9 in a various ways, and if as a human being, definitely we can easily understand it's a 9. These all are 9. But so what our objective is, the computer system also want to understand it's a 9. So what it will do, it will create this 9 or scan this image into pixels, 28 by 28 matrix. So that means 784 pixels, and it will feed this 784 pixels to a neural network, neuron. So a neural network layer. So usually artificial neural network have 3 kind of layer. One is input layer, one is hidden layer, one is output layer. So we feed it to the input layer, and input layer, every pixel we will feed to the input layer, and corresponding to your input layer, we have a lot of connecting layer. That means connecting input to the hidden layer, the middle layer, and every hidden layer have a certain weightage, and every hidden layer have a certain bias. Based on that, only certain point will be activated. For example, in our case, this is 9. So so here it may, the 2 layer, say this B2 to B8, it's activated. then it went to the say the final hidden layer. There it activated only the 4 neurons based on the activation function. And finally, we have the answer can be the 1 light on any of this number, and the only one, the final output is only 9. So it can activate only the 1 1. So for that, we are using something called activation function. These are the technology terms. So you will learn all this after we are joining the courses, or you are learning computer science up to 11th. So we will call it so this is a mathematical way of its identifying, but in output we have just one output. Most of the case, one output. Sometimes if it's a classification, we may have a 2 outputs saying that, okay, this number can be 9 with a 95% probability, but this number can be say 0 with a say 10% probability. It will give those kind of result, not a conclusive result, but a result in terms of a probability. So this is another typical example. We trained the model by using the various say animals pictures, and then we are inputting a dog's picture, and it will take a different edges. First layer will take a hidden layer. First layer will take a various edges, and if it's going to a many layer, it may be many layers. And every layer have it will dictate a part of this animal, and final top layer may have a say it will say limited to the 3, that is and finally you will get an output saying that, okay, 90% possibilities for a dog and 10% possibilities for a wolf. So where is deep learning is using? I will say everywhere. We can use that. This is the future, guys. For example, we can use it on a energy system, because the way we are consuming the electricity, as you know, when we need to consume the electricity at the moment, it's generated. So we cannot store. It's not very easy, efficient to store electricity. Definitely we can store in batteries, but that's definitely not an efficient method because it's a totally inefficient. So the most efficient method is store electricity at the moment when it's generating. So how do you decide how much amount of electricity required today? So based on a lot of analysis on a lot of patterns and a lot of parameters, and maybe your weather condition to n number of historical information, plus some event. Let us consider in the Bangalore city today, there is another event or a concert or some events. So based on those inputs, the system want to generate a certain amount of input, so that decision makers can decide, okay, up to what level of what amount of electricity want to be generated at this particular point of time. So that's one of the application. Another one is a fraud detection from a financial service industry, for example, a banking. How do we identify, does this credit card transaction is original or it's a fraud? So there are a lot of, nowadays we are getting a lot of fraud calls and fraud detection, right? So how do we differentiate that? Definitely we can use artificial intelligence in that area. It's make a lot of advantages in that sense. Another area, maybe I will say the most potential area is a healthcare industry. So we have a lot of healthcare data, starting with our X-rays and scanning reports and our personal informations and our treatment histories and our health histories. A lot of informations are available in the various hospitals and healthcare system. Think about a scenario when we are moving to, what the doctors will do. Doctor will take, say, the X-ray and he will just check, and based on his knowledge and his expertise, he will say, okay, this is this. Or if it's a scan report, it will say, okay, this is a chance for this particular disease, but it depends on his expertise. Think about a system that incorporates the lakhs and lakhs of doctors' input and result. Those kind of this image, this is a result. This image, this is a result. Those kind of data, and based on that, system is learned itself, and system it's incorporating your past histories and your treatment histories, your medicine. So what are the medicines you consumed in past, and what's the result you got? And so that the system can generate and customize and personalized recommendation for you. So that means if there is a small growth in your sometimes your doctor may worry that it's a tumor, but based on the history and analysis, we can say that, okay, the probability for a tumor in your case is less because of so and so reasons. So that much personalization and customization is possible. Yes, that's a technology, this is a technology of future, because how we all of us need expert doctors. Also, expert doctors are not available everywhere. Consider the rural area, rural India. Definitely, we cannot have those kind of expertization. But it's a matter of sometimes it's just a matter of an ordinary doctor, an average doctor, maybe an MBBS fresher. He is taking some image and uploading that image. That's it. he will get an expert opinion in front of his computer. The other way, when you are going to the hospital, say, usually you need to fill a big application form saying that your history or you are allergic, those kind of data. Think about a system that a robot system that just you want to talk to that robot system from your iris or from your voice, it's as identifying you and querying or collecting all the data and talk to you in that time. Hey, Binesh, how are you? So I know you had a fever 2 months back, and but now it's a time of COVID. So if you need to care, so those kind of customization, you need not to input anything. The hospital or the system itself is identifying you. At the time when doctor writing a paracetamol for my fever, it's saying that, okay, it's giving a guidance to the doctor, or an agent or a pop-up giving a guidance to the doctor. Hey, doctor, please don't write. Paracetamol may not be the efficient option for Binesh because last 3 times he used the paracetamol and it's not working. And how ESR is comparably high. So better to go for some antibiotic. Those kind of doctor's aid. Those kind of things are improving. So about the manufacturing sector, where electronics industry, a lot of small pieces are integrated, used in manufacturing. So yes, all these are area where deep learning can do a miracle. That's another important thing. But still there are a lot of limitation for this deep learning algorithm. One is data or data requirement. So if you are taking a traditional machine learning algorithm, yes, still it's required a lot of data, but after a certain point, the efficiency or the accuracy of the model will not increase with the data. But if you think about the deep learning algorithm, because we are not telling the computer or a system what it is or what feature it need to be considered. So the computer itself is learning. So what it wants, it's a huge amount of data. So that is one of the disadvantages. We need a huge amount of data. If we need a huge amount of data, yes, we need to store it. It will need to be stored somewhere, or we need to collect those data and store it. Or sometimes it may not be available. So that's one of the reasons artificial intelligence is a technology today, or deep learning is a technology today and tomorrow. It was not 10 years or 5 years back because we don't have that much data. Now we have that data. So maybe in next 5 years or 10 years, we had that sufficient number of data. Now it's all about using that data. So one is data. That's one of the limitations. Second, it's a computational power. Yes, it's required a lot of computational power because it's dictating each and every edge and each and every corner of the image or whatever the object we are feeding to the system. So sometimes CPUs are not sufficient. We need a GPUs or TPUs. GPU is nothing but a graphical processing unit. It may be 10 times powerful or 100 times powerful, sometimes 1,000 times powerful than our traditional CPU. So sometimes we require a lot of computational power. Yes, so that's another limitation. And third one is training time. Yes, if you are going for a highly multi-layer or huge number of layer architecture or in an artificial neural network, a lot of middle layer or a lot of hidden layer components, a lot of neurons in between, definitely it requires a lot of time to train and come up the result. Definitely the result may be much better than fewer layers, but it will take a long time. Sometimes it will take a months. Sometimes it will take a say weeks and days for getting the model trained, because we are talking about pegabytes of data. See, if you are simply talking about the terabytes of data, it's about a 6-story building completely filled with DVDs. That's what terabytes. The 1,000 terabyte is a pegabyte, right? So say, or zettabytes. Since we are talking about a huge amount of data, so definitely it will take a lot of time. So these are the areas we are, these are some limitation, and these are the areas we are working on. So this is a typical example of an AI system, especially for developing for, answering the questions, many questions. You can ask many questions. That is IBM Watson. IBM Watson is developing a platform. They had a platform and they are improving a platform for, you can ask various questions to say Watson's, and there were many events where Watson performed much better than human being. And another one is a RoboCam. You can see that, okay, robots are playing footballs and they are making, so it's not about remote control. Maybe sometimes like you can see a lot of remote controls and we are controlling the play. No, it's all about the robots. So you can create a team and your robots will play the football. So so you can train the model and the model will act accordingly, because this is a real case scenario. Yeah. And military robots. So this is one of the area, huge investment and huge resources happening on maybe the, say, after say 50 years or 100 years, maybe even less than 50 years. So if there is a combat or if there is a war, say a border issue, no, we human being need not to involve in that. Yes, machine will do that. Those kind of scenarios will come into picture. Or there are scenarios human beings cannot match the mission, its mission's abilities. And there are a lot of deep learning softwares are available like Keras, PyTorch, TensorFlow. These are the software. Try it. There are a lot of small projects, and there are a lot of data are available in public forums like our census data, or a Kaggle is a website where we will get a lot of data. So try it. Download some data and try it. If I time permit, I will show you how it is. There are a lot of easiest methods as well for doing that. And these are the areas for artificial intelligence can be effectively used. I can tell you, frankly, I cannot figure out an area where artificial intelligence is not important. It's very, very difficult. If you see the agriculture field where the intelligence required is sometimes we consider as a minimum. No, there also. So now the drones will take a picture, drones will just fly over our field and it will take a picture and it will say, okay, where we need to use the pesticides and or where is the weeds and where is insects and which proportion we need to mix and just put that on that drone and it will automatically will fly again and it will spray that pesticides and not entire field, only at the place where it's required. Depends on based on the mixing or a concentration of what is best suited for that particular area. So human being, we may unable to see all these say fungi and some insects, but the machine will detect that and it will spray in the proportion. And next time when I fly, it will take that historical data and it will study from that. Okay, I sprayed last time, say 2:1 ratio here, but it's not effective. This time I may need to 1:1. So mission will learn and will do that. See a scenario where a farmer's ability is replaced by a mission much efficiently, even much financially efficiently in the case of a large farms. So that's what it's everywhere. You can see artificial intelligence everywhere. And this is the sum of the open source technologies we can see like Apache Spark, Kafka, HSpace, and Spark ML is a machine learning. And this is a RStudio, Jupyter Notebook, Spark, H2O, Datalang, Data Robot. There are a lot of softwares, open source softwares are available nowadays for deep learning as well. So you need not to worry about paying something for the deep learning. Even you can use the cloud infrastructure for Amazon Web Services. If it's, I believe it's a $250 or $300 is free for you to use. So for 1 year, $300 is free. You can try anything you want, and it will not charge you a penny. So like that, there are a lot of data science tools are available nowadays. So 5 development that I personally believe, based on my knowledge, that's going to may take shape from 2021 and beyond. One is AI and vaccine development. Typically, we know that to develop a vaccine, it will take years. Sometimes it's a decades. But in about the COVID vaccine, so we came to know that within the 3 months of first report cases, some companies start trial of this vaccine, undergoing human tests. This has happened, and I'm not mentioning that industry, but this has happened just because they employed artificial intelligence on their research. So how fastly things are doing, because the computational, definitely the computational capacity, they require a huge amount of computational capacity, but that's available in cloud. So those capacities are available in cloud. Second is, the second possible option is, yeah, as I said, the fully automated driving and rollout of robot taxis. So yes, it's not about just a self-driving car. You are getting a taxi and you just need to tell, okay, where you need to go, and the system, the robot, the car will automatically take to that place. That's one of the area. That is microelectronics plus mechanical mechatronics. That is mechanical plus electronics plus computer science and data artificial intelligence. Next one is applied natural language processing. Like I said, a hearing aid, that aid or some equipment, a small devices inserted in our ears, so that can convert any language to the language, our native language, those kind of scenarios, so that we can talk to anybody and there is no language barriers. That's another area. Another one is a quantum computing. That's a very, very fast evolving area. So usually we are, say, working with a computer that have only binary computer, because 2 states, 0 or 1, high or low. That's our binary system. So we are moving to a system where there are much more states. So if that's the case, all the computation will be very fast. So that's another, and it's a helping each other. The AI helping the quantum computer and its growth, and in the vice versa. Another area is AI chips. So that's very important, because now whatever the computer what we are using, either CPUs or GPUs or sometimes TPUs, that is developed for general computing purpose or something. GPUs is some little more graphic intense computing. So, but it's not for AI, but we are also developing chips just for AI, the chips that is specifically tuned for AI. Once that chips are in place, yes, it's going to make a dramatic change. And so another important aspect, so that is there are some threats. There are a lot of good things we learned about this artificial intelligence in recent in our era, but there are a lot of risk and ethics comes into picture, like drone attacks. So as you know, our nation faced a couple of drone attacks in the last few months, right? So how do we stop that drone attack? So drone maybe flies at 200 meter or 300 meter, maybe sometimes more kilometer range. And then from there it will act. It will maybe dump another set of 10,000 drones, and it will attack our, say, defense systems or some highly populated areas. So definitely we need a set of ethical practices up to which level we can go on this artificial intelligence. So sometimes it can surpass human abilities. So, and it may conquer its own. Most of you guys may heard about, say, Facebook AI engines developed its own language on 2017. As a result, it start communicate its own, because we developed it for some purpose, but lately the system itself developed a language and start communicating its own, and it stop responding to what we are asking. So those kind of scenarios are also possible. So it can be a threat to the human society. So definitely we need a set of rules and regulations and in place. So some risk what I identified is deep fake. Deep fake is something like, so it's creating a fake video of you. That means something you never know about, but it's in your voice and your picture and in your way, and it's propagating that or spreading that videos, and or in our current terminology, viral that videos in the social media. Sometimes it may trigger some communal violence, or it may have a lot of impact. So that is one of the largest threat, that is deepfake videos. Apart from that, we have privacy violations, algorithmic based causes, and socio-economic inequalities. That means most of our farmers may go out of, say, job if the systems that take over in that aspects on market, weapon automation, etc. These are some challenges, but yeah, deepfake is something that's very important, and we are almost near to that. So I will show you another video and how the deepfake works.
Welcome to Watch Mojo, and today we're counting down our picks for the top 10 deepfake videos. For this list, we're taking a look at the most seamless and strangest videos made possible through the human image synthesis technique known as deepfake. In case you're unfamiliar with the term, deepfake software essentially allows users to swap out an image of one person's face with another through artificial intelligence, which is what we're focusing on here. We're excluding mashup images of animated characters, as well as videos that just use simple editing filters.
This last name. Now,
Number 10, Jimmy Fallon as Paul Rudd. Jimmy Fallon and Paul Rudd share a fair deal in common. Both are funny men, both are musically inclined, and both have somehow managed to maintain perpetually youthful appearances even as they enter middle age.
oh my goodness. Well, good to see you. How's it going? Oh, really good.
The two even kind of look like each other with dark brown slicked up hair and clear pale skin. Their likeness is only made more apparent through this deepfake video, which plasters Fallon's face onto Rudd's head. Looking at the side-by-side comparison, the viewer may assume that they're seeing double at first. Focusing on the right image, however, it becomes clearer that Fallon has possessed Rudd. Still, we never realized just how eerily similar the resemblance was until we took this journey into the uncanny valley.
You make me want to shout, keep my heels up and shout, throw my hands up, shout, throw my hands, I can shout, come on down, I can shout a little bit louder now, shout a little bit louder now, shout a little bit louder now, a little bit louder now. Hey, hey!
Number 9, Hillary Clinton as Kate Mckinnon. It's It's no secret that comedian Kate Mckinnon can do a spot-on Hillary Clinton impression, nailing her voice, mannerisms, and appearance to near perfection. You're finally going to announce that you're running for president. Gosh, I don't know if I have it in me. I'm scared. I'm kidding. Let's do this. Mckinnon practically becomes Clinton on SNL, but this deepfake video takes matters one step further. With Mckinnon already sporting Clinton's signature hairdo and wardrobe, the video seamlessly sews the politician's face into the equation.
I'm sorry, Lester. This is going so well.
If you were to just look at the deepfake imagery, you might assume that this is a real clip from the 2016 US presidential debate.
When I was Secretary of State, we actually increased American exports globally 30%.
Honestly, considering how crazy that election could get, it was often hard to separate satire from reality. Likewise, this deepfake video is where artificial intelligence and actual intelligence intersect.
Exactly how I always dreamed.
Number 8, John Oliver as Jimmy Fallon. Lip sync battle has become a staple of The Tonight Show starring Jimmy Fallon. In the original clip used for this deepfake, Fallon competed against Emma Stone by lip syncing to Iggy Azalea's Fancy. Swapping out Fallon's voice with Azalea's is one thing, but swapping out his face with John Oliver's is another. This deepfake is so realistic that it almost tricks the viewer into believing that Oliver is the one lip syncing. Of course, it becomes more evident that we're watching a deepfake when the camera briefly cuts to Stone, who's given thick glasses, a larger nose, and bushier eyebrows. Another clip shows Fallon's voice coming out of Oliver's mouth. It just sounds bizarre since it's impossible to imagine Oliver without an English accent.
Hey, Team USA. Do it.
Number 7, Vladimir Putin as Beck Bennett. Russian interference has been one of the main talking points following the 2016 US elections. Only a day after Donald Trump was sworn in as President of the United States, SNL opened with Beck Bennett doing his impression of Russian President Vladimir Putin, without a shirt on, we might add.
Yesterday, we all made Donald Trump the 45th President of the United States. Hooray, we did it!
Although Bennett made Putin look pretty silly, this deepfake video upped the absurdity by 304 electoral votes. Between Bennett's exaggerated accent, the fact that he's topless, and the phony Russian background, it's obvious that this isn't the real Putin. Nevertheless, the deepfake is still surprisingly convincing, virtually consuming Bennett's body. Given the current political climate, we're not sure whether this deepfake is hilarious or deeply disturbing.
Many of you are scared, marching in the streets. You are worried that your country is in the hands of this unpredictable man. But don't worry.
Number 6, Sylvester Stallone as the Terminator. In the movie Last Action Hero, it's revealed that Sylvester Stallone has replaced Arnold Schwarzenegger in his career-defining role.
No, it isn't possible.
That's impossible. He's fantastic. It's his best performance ever.
But that was you. You were in that movie.
The visual gag is only made funnier when you consider that Stallone was eyed to play the Terminator in real life, but he turned the part down. Although we get a poster featuring Sly as the T-800, we sadly never see a clip from T2 the Stallone cut. Over 25 years later, a deepfake video made this alternative casting choice a reality.
Smile once in a while.
Smile.
Granted, it is rather jarring hearing a thick Austrian accent emanating from Stallone, who also has a very distinctive voice. Nonetheless, the face swap is damn impressive, especially when Stallone's Terminator attempts to smile.
So guys, that's how the deepfake works. So it may be very difficult to classify, and most of these materials will be available on the website. Especially when you are searching in the website, try for say, some university portals as well as some well-known institutes, including say MITs and even our JAIN universities. And there are a lot of institutes have a lot very authenticated documents, and some popular journals also publishing a lot of material in this context. So high level, that's all for now. And yeah, I believe we may have a couple of poll questions as well. If possible, just run those poll questions. And yeah, then it's a time for a Q&A session. So yes, this is the answer. Yeah, deep learning is the right answer. So we got a 45% of the participants. Yes, believe the deep learning is good for the complex image processing. Yes, that's a very good. And yeah, can you please run the next question, please? Which of the following is an application of an AI? So gaming, natural language processing, cognitive services, and all of the above. Choose one answer, please. It's a straightforward. I believe all of you get a chance to do a answer. And if so, we can close it and yeah, let us see its result if it's available. Yeah, all of the above. That's the right answer because gaming, yes, that's one of the area. So very interesting area. Natural language processing, yes. Cognitive services is nothing but detecting the object and voices and working on those kind of services. Yes, yes, that's also another area. And all of the above is the correct answer. Yes. So I believe we may have one more questions, right? Do you? This is a little tricky, and but we covered this. Does the data set size influence a machine learning algorithm? That's a question. So choose most appropriate. We have 2 yes answers and 2 no answers with a condition. Yes, the quality and accuracy of the model increases as data size increases. That's the first option. Second, no, the quality or accuracy of the model not depends on data size. Third, size, yes, but above certain data set size limit, the model quality or accuracy will not increase proportionately. Is another answer. And no, the model quality but accuracy depends on only on the algorithm. That's what the fourth answer. So it's a little tricky and it's required a little more attention because we show while in the slide presentation definitely use a graph, and from the graph it's easily readable, and we also discuss about this. So for this, I may give a little more time, maybe a couple of more seconds, because it's a little challenging one. I believe all of you got a chance to click at least one of the button, and let us close this. And if once the result is available, just show to us, please. Yeah, yes. So definitely all of you are smart. Yeah. So yes, that's option C is the answer. Yes, it have a lot of meaning up to a certain level, but beyond that, still it will improve the data, the quality, accuracy of the model, but it's not proportionately. Why we are not using that? Because the computation is always an expensive thing. So let us consider. So you have a 2 model. Model A give you say 95% accuracy within say 5 seconds or 10 seconds of time. You have another model B. Model B give 96% accuracy, but it's taking 10 seconds of time. Which one we will choose? Purely depends on the situation. If it's a medical case, I may go for the higher accuracy. But remember, 5 seconds to 10 seconds, it's on a huge infrastructure, huge computation power. If you are running on top of that, definitely the cost will always double. Maybe sometimes it may not be double, sometimes it's more than double, sometimes it's somewhere near to 1.5 times, but it's much higher than the first method. So 1% accuracy increase, twice the cost difference. Do we buy that? Purely depends on the scenario. Some cases, for example, if it's something say classifying or checking, does this person have cancer or not, is a malignant or benign, those kind of scenario, yes, it's more than the cost, the accuracy is important. But some other scenario where we may be okay with a certain amount of information, does this particular say decision want to make in this way or this way? So maybe you may have a different, definitely to have different values and different value propagations. But in that case, we will choose one. We may go for the option 1 because the 1% does not going to make a big difference. So it depends on the scenarios. So I will take the questions now, and yeah. So let me see if we have questions. We will start from here. Oh, Alexa, come into narrow or general intelligence. My friend, it's a narrow intelligence. We are in the process of finding out something, give a general intelligence, but it's still under research. What are you saying about a misconception on AI and ML? That is, AI lead to unemployment, etc. So definitely there is a possible. So that's our perception. If we are not, see, years back, the doctors got the stethoscope. Up to that moment, how doctors came to know about the heartbeat? They use their fingers, right? And definitely there are a lot of doctors, maybe we will call as a local doctors. They use that finger and identify the diseases. But we have a formal medical practice in pictures, and we have a stethoscope, X-rays, and other diagnosis devices. Does that replace doctor? No. But that replace doctor, they are not ready to accept those changes or go with those changes. So yes, definitely AI going to replace you if and only if you are resistive to that technology. So if you start using that technology, definitely it's an additional weapon, additional engine. So due to a lot of luck, I'm one of the person who got an opportunity to work on this field maybe from last 15 years or last 10 years mainly. And I know, I can tell you with confidence, this will be the technology of tomorrow. There are a lot of things that we can automate, and we will do that. Irrespective of you like or not, definitely that's going to happen. So you have two choices. Either be a front runner, learn about the technology, or be a part of that technology. After some time, you may be the leader in that technology. Otherwise, so find an alternative way. So it may not be too easy. And so sadly, I can say even some hospital in China, they reduce the number of doctors who do the RD, radio diagnosis. So, to get an MD RD is one of the most difficult. If you're getting an MD RD was most difficult maybe few years back in our, say post-graduation medical education, especially All India Institute of Medical Science or some other institutes, some good reputed institutes, getting an MD RD, radio diagnosis may be very difficult because that's considered as a most reputed job, the job that requires most intelligence. Because you are checking a certain set of images and evaluating the images. From that images, you are saying that, okay, what is the disease it is. So we are talking about such profession. Now the computer will do much efficient than human being in many cases. So what's the best way? So use that potential, make it as an aid and use that potential. And yeah, that's the same for every field. So definitely AI will take over certain things that machine can do much efficient than us. Yes, but still we have a lot of scope, and we need to be part of that journey. That's all. Have you marked my attendance? That's nothing related to this. What is the answer to the first poll question? It's Australia. Australia made that changes. So there are many other nations made that changes, but that dramatic changes made by Australia, overseas. Yes. And I could not answer the second poll. That's fine. Answer second poll, but it's not registered. Okay, it's a technical issue. That's not an issue. We can know that. When I click the button, start it's closed. Okay, that's also fine. Why should we prefer Why should we prefer this? So if your question is about artificial intelligence, I already told you the answer. So in previous, I can give you my personal experience. In my company, if somebody is making a complaint, it will take around 72 hours to attend that complaint. That means they need to call to our call centers or want to write an email, and we will take their details and put it on our trouble tickets. Means a repair ticket, and repair ticket will get to and assigned to an agent, and see a technician will see, okay, if my skill is good enough for that, or if it's not, he will reject and will put assign to another person, and this person will go to his house, and at the time when he reached first time, there will nobody there, and he will come back, and next time he'll go, yes, and will do the repair. Sometime first time he may not have an idea, he may be a TV technician or an expert on TV services, but this is for telephonic services or some data storage services. Yes, he don't have any idea. Okay, this is how the things work. You know how it is working now? Just click a button and say, okay, my name is Dr. Binesh Jose, and my account number is 207-80903. I have an issue with my TV service. Done. You are done. That's it. So first, what system will take? System will take the keywords and I will recognize the language, and based on that, immediately system will ask you, hey Binesh, can you do a favor? Can you please take a picture of the device? Fine enough. It may be my router or whatever device. I will take a picture. Immediately my system will classify this, because we may have thousands kind of field equipments. So we will classify it into one group. Once it's into one group, that's a classification, it will do a clustering algorithm. We'll check what are the lights in that particular device is blinking. So then based on that light, we will come to know, okay, it may be like this, or this is the complaint. So we have a background Unix script that's running this, and it will reload the configuration. It will do some rebooting, and most of the time we will get a positive result. 70% of the cases in my organization, we will get a positive result. And immediately, this all will happen within a span of a minute or two, hardly 5 minutes. Immediately, you will get a message saying that, okay, Binesh, it seems to be your issue is resolved by our automatic system. Can you please check and let us know? Yes. If it's not resolved, yeah, if the system is unable to handle, it will still check what is the chance Binesh leaving this organization or leaving our services if we are not attended within an hour or within 2 days or within 5 days. And based on that, it will create a plan and it will assign the technician and prioritize it. And it will immediately send a message to Binesh saying that, okay, Binesh, okay, your trouble ticket is assigned to this technician and this is his cell number. He is planning to come tomorrow at say 3 p.m. So if you are not available at 3 p.m., reschedule it. Just a button, just click, and it will pop up an available slot. You can select a slot. You are done. Technician will come and resolve. It will hardly take, in our case, less than 2 days to resolve all the issues. Previously, it took months to resolve all the issues. Automation, a 70 to 72% automation. That's what happened. So if that's possible in the industry, we made that happen. Who? Data scientists, or the guys who are doing this artificial intelligence stuff. How we view us AI as emotional support tool? It's a very funny question. Yeah, very interesting question, definitely. And I have a funny answer for that but because of the camera issue, because I only have one camera, I cannot show that. Before this course, before this today's session, actually, I plan to give a small demo. For that, I write only 6 lines of code, 7 lines of code. It will check my face and will find out, it will tell my emotion. See, mine is just an average laptop. And it's a i7 processor, maybe 8 gigabytes of RAM. It will able to find out the emotions. So tomorrow, maybe when your kids are in school, they may first will take a photo or a video from you, and then the system will, by using AI, and will understand or will decide whether this is the right time to go with their mark record. Yeah, that's very much possible. Face recognition and comparing various points, how it's a natural case and how it's in a various scenarios like that. Is it another level of coding of software engineering? Yes, it's another level of coding, but my personal experience, I'm not a very much passionate guy on a traditional programming way, but I'm very much interested in machine learning and deep learning or artificial intelligence area, because it's a coding area, but it's not only coding. As I said, 60 to 70% of the time we are spending for cleaning the data. So there are a lot of things we can do in between. Sometimes the pin code in the address doesn't have any impact on the result. But if you convert the pin code into a district or a state-wise or a region-wise, it has a big impact. So that is what is called feature extraction, feature selection, feature engineering. So these are the very interesting area. And yes, it involves certain amount of coding, but yeah, much more than that coding. Artificial super intelligence, definitely no. That's what, see, this is an open technology. We have a lot of knowledge. So you can develop, I can develop, and terrorist organization also can develop. So ethical practice in AI or some organization like some leading organization like Google or Facebook or say Nielsen or some other organizations, they are doing AI very responsibly. They will not go for an AI in even the very controlled way, but still there are some persons, they do AI in a very different way. So the only one method is we will say precaution is better than cure. So to do some kind of precaution. That's what our national research and national security agencies are doing. They are doing also research agencies are doing, say, DRDO and other various national agencies are doing those kind of researches, how we can prevent these kind of things. So super intelligence, is it essential? Definitely not. Not at this point, but who knows? Maybe we are now talking about aliens also, right? So if you want to fight with aliens, sometimes we may need someone much more powerful than human. Yeah. Yeah, I revealed the first answer. I attend 9 sessions administrative question. What's the disadvantage of AI? That's what. AI can be used for a lot of risky scenarios or unethical things as well. That's a major disadvantage of AI. So it's a historical data. And yeah, there are a lot of challenges getting the data in right format, but a disadvantage can be used for unethical practices. And see, as I said in our example, say the doctors, that chat engine or that robot or a pop-up can guide doctor in terms of a medicine. At the same time, that can guide doctor in terms of saying that, okay, this is Binesh, he have a good income. His last month he got a salary hike of say 2 lakhs. Let us go for a scanning. That's also very much possible, right? So we can have a lot of business tricks also comes into picture when technology involves. So yeah, if it's used unethical way, that's definitely that's one of the disadvantages. How artificial intelligence into machine learning? Machine learning is a subfield of artificial intelligence. Artificial intelligence have many tasks and many things involved. Machine learning is one of the popular field that's a subset. Just like your say data science, data engineering and computer science. Computer science is a broad field and data engineering is one of the subfield like that. Is Terminator and artificial general intelligence? Yes, that's what it's a imagination of artificial general intelligence. Yes. Again, we know this Terminator cannot program. We never see Terminator doing a large program. So definitely, when we say general intelligence, it do most of the general things as a human being, but it may specialize on certain area. Yeah. So it's come to a super intelligence. A person, they have a excellent in many fields. That's what we call super intelligence. Now, first poll answer I said, yeah. How does a day in your life look like? So yeah, so as a computer professional, I'm a practice head for a large telecom company. So in a typical day, I have around 60. I involve 60% of the technical stuff and 40% of the management stuff. Management stuff means we have a lot of challenges, what partners, vendors, and roadblocks, a lot of issues. So we will discuss together and we will come up with a standard answer most of the times, and or mutual agreement. So dealing with a partner and creating an ecosystem of partners, vendors, and customers, so that everybody is aware about what is risk, what is shared risk, what is we are trying to implement, what is the time frame we are talking about. More importantly, what is success really means for various parties involved. That's what my management was. Come to the technical task. I work with my technology team on designing architectures, designing algorithms, or mathematics is very important in this context. Say, you need not to be an expert on mathematics. Mathematics is simple in this context, but you need to understand mathematics. So understand mathematics, or say, find out the various algorithm we are using, where it lacks, how we can improve. So discussing with the data scientists in that context. Once we have a lot of experimentation, my team do. We will do a lot of experimentation. It's an innovation driven team. So we have a large team, 106 team, just for this artificial intelligence area. It's a globally distributed US, India, and Philippines. So culturally diverse team working together. So there are a lot of those kind of issues. So they are working as a team. So a lot of those kind of discussions, reviews. There may be a potential area that may be say bottlenecks tomorrow. We will discuss about that area. So as a team will work. At the same time, sometimes my developer may have an issue, and I may need to sit with them. At the same time, my CEO may call and ask me, okay, where the technology is heading towards, or how we can say plan. We are in very near to 5G implementation. So how do you going to use the potential of 5G on your artificial intelligence? So definitely those kind of discussion. That's what my typical day is all about. You will get in say materials and videos from many sources, but I strongly recommend go to some standard universities, and for NPTEL, say you know what is called NPTEL. That's our all IITs and all reputed universities videos, classes. That's another forums, and you can have a lot of say certification bodies like Coursera's and EDX, a lot of such kind of organizations, and even JAIN University is conducting a lot of courses in these times and graduation. Maybe I will say, if I am in your place, I will say I will go for a graduation. So fundamentally I am a computer graduate, but if this is my era, I will go for computer science or a data science related stuff, and will focus on that. And from day one onwards, I will spend some of my time on this advanced technology. Yeah, lot of material, but be selective. Go for only authentic material. Okay, thank you very much. I appreciate your time. Yeah, bye.